Hello students, welcome to the Yupp Master School Foundation program. Today we are going to discuss the important topic. What we are going to discuss about all these, you will see with the animated videos and well crafted diagrams and modern teaching methods are very useful for you to solve the problem. You feel very happy. Let's see. And what we are going to deal, we are going to discuss the advanced model problems on units and dimensions. Just you will see that. Yes. What we are going to take that? We are going to take that level 3 problems, advanced model problems on units and dimensions. Already we have discussed about that units and dimensions in the previous classes. It is very clear. That's what I am telling you. If you are going to take a one derived quantity, its dimensions are going to be verified. Right? Please see that. Right, what we are going to take that. Let's see, have you seen this one? This is a simple circuit, let's assume. By getting this one, this is R, this is a capacitor. Yeah, it's going to be taken, this is the input, we are getting this. At the same time, if you are identifying this, first let us discuss about this circuit. From the given circuit we can understood we are supplying that input voltage through this R, that C is a one device, that is a capacitor. It will stores the charges, simply it will stores the charges. Alright, now you will get the output. This is going to be output. Yeah, this is the output. You are going to get this, measure the output. Now, from this one, what we are going to learn? We are going to give that input voltage. With respect to the time, the charges are deposited. Here we are going to be get charges are going to be here, right? It is very clear. So the charges are deposited on the one plate of the capacitor. Capacitor is a one system, one device which stores the charges. The system of two plates which are having the equal area in size and they are going to be accepting the charges. One plate is going to be positive, another one is going to be negative, which is grounded. You have learned this is why we are going to take this one, we will see that. So that electron is going to, we are applying, yes. So we are going to take this one. Right? That electrons are going to move, right? They are moving. Very clear. Yeah, capacitor. This is the, just we will take that. One thing you can commonly observe that when they are allowed to move from one area to another one, they are going to get the collisions. There exists a resistance, no doubt at all. If you are going to identify this, what about that as time increases, the charge deposition, the capacitor charge increases, no doubt at all. What is the saturation point? It will have some saturation point. After that, it doesn't allow the charges. It's very clear. Now we are going to take that the current is or voltage with respect to the time, they are going to get this variation. If you are going to take that one phenomena, we have given that voltage and we are obtaining that current which has been measured with the instrument. Now you can take that basic law, that is V is equal to IR, right? This is very clear. Now if you are going to get this one, this is one, the current I is going to be I is equal to Q by T. If we are going to take this one by T, charge passes, how much amount of that charge passes. If you are going to take that, the charge of electron is Q, and the time which is allowed to pass, that is going to be T. It can be identified. At the same time, you have to know these fundamentals, which are very, very important. All right. Now, if you are going to take that, if you are taking that, it's very clear. Let us discuss this one. We will take that. Yes, this is Ohm's law. What we are going to get, that is Ohm's law. All right. If you know that capacitance, that C is equal to Q by V. These are the three important relations to know that C is equal to Q by V. Please remember all these things. Why we are going to discuss all? Very simple. If you are going to take that, this RC circuit, you have that problems which are related to dimensions of a RC, dimensions of a IR, and some problems are designed based on this circuit. Just you can see that, right? Yeah, the dimensions of RC. Yes, you have to take this one. All right. So, what about R and C? Just you have to see. R, it was having that ohms. It was having the units. C, it was having that unit farads. Yes, it was measured in units farads. The dimensions of RC is going to be square of the time, square of inverse time and inverse time. Okay, let's see that. if you are going to take that relations, yeah, V is equal to IR is the first one, I is equal to Q by T, that is the second one. Suppose you can take that from this one, can you write R value, that R can be written. Can you write this C? Yeah, what we are going to obtain, this is C and this is R. We know that R is equal to V by I. Alright, that is very important. We will take this one. Yes, we are about to take this. Dimensions of RC, you are going to take that. Dimensions of RC, we will solve this one. Right, we will use this space, that is RC is equal to, we are going to get that. Previously we know that V is equal to IR, R is equal to V by I. This is the first one, let us assume. Now you know very well C is equal to Q by V. This is the second one. What is that additional information? That is current I is equal to Q by T. We are going to be learn. Amount of charge, if you are going to take that, the current is nothing but the amount of charge crossed per unit area, unit time, by applying the 1 volt potential, that is 1 ampere. If you are going to take that, charge has been transferred in a time interval of t, that is charge crossed per unit area bearing the resistance, or by applying the 1 volt, that current is known as 1 ampere. Very clear. Now you are going to know that current I is equal to Q by T. This is equation number 3. Alright. Now you have to take this relation, yeah, R into C. Just you will substitute this one. Yes. While you are going to take that dimensions of RC, you know that what about R, what about C? It is very, very important. You can put this. Can I place here what I would like to get this one? What I am going to write down here from this one. R is equal to V by I. Yes, this is going to be written as V by I. Yes, what we are going to write here? What we have to write? C, that is Q by V. So it is going to be cancelled, that is VV cancelled. So finally it is equal to Q by I. Yes, Q by I. You know, current I is equal to Q by T, T is equal to Q by I. Just you can take that, Q by I. So this is equation number 4, this is equation number 5. Let us assume. Right, we can substitute this one. This is 5, this is 4, let us assume. Just what you can write instead of this one, therefore RC is equal to Q by I. Alright. So that is equal to T. So what about RC? Finally we are getting time. It's very clear. So the dimensions of RC is equal to time. Very clear. While you are going to consider, R is the resistance, it's ohm, C is the capacitance. But how it is going to be related to the time? Just we have to see that. Previously it is very useful. Alright. Now let's take this one. It's very, very important. Even though if you are having this information, just you will recap. That is Ohm's law and capacitance of a capacitor and that current, how it is going to be related, right? Very simply, just you have to get that RC, the dimensions of RC is equal to T, what we have obtained. After all this discussion, you will confirm this one, it is very clear. This is the advanced model problem. Please, they are going to ask that these type of questions on circuit analysis based on the circuit. Some inductor is also there in the circuit, LCR, and other circuits also there, right? You will apply that laws, what you know, that you will apply that basic rules to solve the problem. It is very clear. Now let's go for another one. Yeah, frequency of vibration of yeah, they are going to take that case. It's going to be taken, it's going to be attached by the mass. So you will take that, when it's going to be taken, you have to take this one. Yeah, it is having no mass, let's assume. Yes, you can take this, when it is attached by the mass, you will take that, right? If you are going to take that, this F is equal to minus Kx, x is the displacement, you know, x is the displacement. We are going to take this one, basic law. So it is going to have that vibrations. When it is attached to the mass, it is a system having mass. When it is going to be attached to a mass, what happened? It is getting some vibrations. Yeah, you will get that vibrations. Now you will take that frequency, you will take the phenomena of frequency. Yeah, it is very clear, when the spring has been attached by mass, what happened? Automatically there exists a set of vibrations which may be related to the problem. Frequency of vibration, that is given F, all right. Mass, this is M, all right. And that according to the Hooke's law, very clear, this is yeah, F is equal to minus Kx. Very clear, we are going to take that negative sign which is going to get that opposite direction. That indicates that opposite direction, no doubt at all. Now you are going to attach the mass, that force is in this direction, but the spring, it shows that restoring force to regain its original position. Spring is going to, it is opposing that the change. So the restoring force is acting in opposite direction. So negative sign indicates that opposite direction. Due to attached mass there exists a force, all right, that is going to be having, the restoring force is going to, in opposite directions you are going to have that system of force, right. All right, K is the constant, K is the spring constant, K is the spring constant. All right, you can solve this problem, no doubt at all. You know that. What is that? X is the displacement. X is the displacement. Very good. Now you can solve this problem. The basic relation is frequency F is equal to, yeah, we can use this space, frequency f is equal to a into m power x k power y. All right, that's what I am telling you, how they are framing this relation. Listen, that f depend on mass. All right, f is depending on mass. F is also going to have that relation by getting this. Yeah, and you know spring constant, that is going to be k, it is going to be expressed as the relation. Yeah, you can take that f, it is going to be related on k. So this is the one relation which is very, very important. A is a constant, dimensionless constant. A is the dimensionless constant. But what the question, the values of x and y, you will take that. You have to calculate the values of x and y. X is equal to what? Y is equal to what? That is the question. By applying the dimensional analysis, you will solve this problem. You know the frequency, you are going to get that frequency. It is easily identified, that dimensions, right? So we have to write down and we have to apply that homogeneity principle. Left hand side and right hand side both are going to be equal. You will take that f, they are going to be having that dimensions m power 0, L power 0, t power minus 1. Yeah, frequency is equal to 1 by t. Just you will take that. This is the case. We are going to take this one. Right. Now, m, if you are going to take this one, that is m power 1, L power 0, t power 0. All right. What about k? You are going to get this k, that is equal to, yeah, from this one, do you know k is equal to f by x. K is equal to f by x. You know that dimensional formula for x, force, and you know dimensional formula for the force is ml t minus 2. X is represented in its dimension length L, that is, therefore k is equal to ml t minus 2 by L. So it is going to be cancelled, L is going to be cancelled, that is m t minus 2, right. Now we would like to write down here k is equal to m power 1, L power minus 2, t power 0. All right, we have written for f, m, k, and for a is a constant. It can be written as all power 0. Just we are going to apply that, powers are going to be compared. According to the principle of homogeneity, you will get this comparison, left hand side and right hand side, they are going to be equal, right. So can I erase this part for this simple understanding, right. All right, just you will get this one. Get this, right. Now you will take this equation, this is 1. From this equation we can write down as m power, just we will take this equation, that is very clear. Yeah, we know that f is equal to a into m power x and k power, yeah, k power y. So we will take this one, m power 0, l power 0, t power minus 1 is equal to, we have to write down the help of this equation, that is for a what we are going to write down, m power 0, l power 0, t power 0. For m we are going to take that m power m, this is, yeah, this is going to be substituted in this expression and we will solve this one. Right, m power 1, l power 0, t power 0, whole power x. Right, now you can take this one, yeah, that is k. For k you can take this m power 1 and l power minus 2, t power 0, whole power y. You will take that right, you should compare this one, left hand side and right hand side are going to be compared. Now it is very clear, m power 0, l power 0, t power minus 1 is equal to, here we will like to take that this is m power x, alright, l power, just you have to take this one, l power 0, just you are going to get this one, yeah, l power, please take this one, we are going to get here m power 0, this is m power x and m power y, yes, and you can take that l power, what we are going to take this one, l power 0, l power minus 2y, right, we will take that m power x plus y and l power minus 2y. Here we would like to get this m power 0, l power 0, t power minus 1. All right, just you will take this one. Now easily you will find out that, please have a look, yeah. For k we are going to write down, for k what we have to taken, that is if you are going to get this one, please wait some time, just for k we are going to get k is equal to f by x, that is m l t minus 2 by l, l is going to be, yeah, for k you will get that m t power minus 2. So here we would like to take this, yes, all the people has to follow this one, please have a look. We are going to get this one m power x, m power y, and while you are going to write down, that is t power 0, here t power minus 2y, all right, this is t power minus 2y, very good. So LHS, RHS are going to be compared, powers compared, powers are going to be compared. So homogeneity, according to principle of homogeneity, just we are going to get that, compare that powers, that is x plus y is equal to 0, that is minus 2y is equal to minus 1. So you will take that y is equal to 1 by 2. If you substitute the x value, you will substitute in that, you will get this one. We are having that y is equal to this one, and you will take that x plus 1 by 2 is equal to 0, x is equal to minus 1 by 2. All right. We have been solved that x is equal to minus 1 by 2 and y is equal to 1 by 2. Very good. This is the correct answer. You are supposed to get that. Fourth one is the correct answer, which is suitable. Here we would like to take this k, this one. All right. This is a simple problem. It is going to be based on this concept. Now we would like to have that comparison on the left hand side and right hand side. Here the powers, the base is going to be raised to the particular quantity on these two cases, first one and second one, left hand side and right hand side, their powers are going to be compared, and you can add this one, just we are going to add this one, it's very clear, and you are going to take that, the powers are going to be added very simply. Now it is very clear, we can solve these kind of problems simply. Okay, let's go for another one. Yes, yeah, you can take that. This is a one problem. If velocity v, force F and time t are taken as a fundamental quantities, then which is correct for this one, right? Then dimensional formula of mass and energy, we have to verify that, which is correct, right? If you know that this fundamental quantities, just we are going to verify all these things. Now which is the correct one, you have to take this one. Yeah, we are going to take that. Yes, force is equal to mass into acceleration. Mass into acceleration. So F is equal to m L by t square, right? Acceleration is going to be L by t square. You can write here, we would like to take that, very clear, just we have to take this one. While you are going to take that acceleration, it is related to change of velocity. Easily we will find out this. That force is related to this term, yeah, t, and velocity also. Yeah, you have to take that. There is a one relation. You will find out this relation, that is mass into acceleration. Force is equal to mass into acceleration. These are the base quantities, let us assume. Therefore, F is equal to m L by t into t. Very good. Now you can split this one. F is equal to m by t and L by t. All right. Now you can write down F is equal to m by t into, this is v. This is v. Now since L by t is equal to v, velocity, it represents that velocity. Therefore, you will get this one, Ft is equal to mv. Therefore, m is equal to, please write down, m is equal to Ft by v. All right, it's very clear, just you have to go this one. What we are obtained, therefore, m is equal to, we will take that, Ft v minus 1. So this is very clear. They are given that the fundamental quantities are going to be Vft. Okay, you are going to express that mass in terms of this one. Please see that. The dimensional formula for the mass is, yes, it's very clear. For the mass is, yeah, what they have given in the first option. Just you will take that m is equal to v minus 1 f t. This is the correct one. First one is the correct one. All right, for energy, per pressure and all these things we can do that. We will calculate also. Let us take that, which here this is going to be wrong, this is also going to be wrong, this is also. If you want, just we will check it. Let us take that second one, it's very clear. Now we will take this one. This is correct, already we have verified. This is going to be correct answer, no doubt at all. Right, we would like to go for that energy. We will check. Right, you know that energy is equal to, we are going to take that either kinetic energy or potential energy. Let us take that kinetic energy. If they have given the force and velocity, okay, kinetic energy, that is half m v square. We would like to take this one m v square. So m energy E v square, that is L by T whole square. So we would like that, we would like to have that E is equal to m L by T into T. Okay, otherwise we will check in the different procedure. Work done is equal to energy. We will take that, this relation, we will get the final relation. Just you will take that in another form, work done. Yeah, you will take work done is equal to force into displacement. Very clear, that is equal to energy. So if you are going to take that, you are going to have that force. For that force you will write on F and displacement. Yeah, you will take that. It is going to be force, displacement is going to be L, that is equal to E. If you wants to get that, if you multiply on this case, just you will multiply with T, multiply and divide with T. Just you will take that L by T into T. So you will get that F into V into T. Yeah, it's going to be taken VFT, but you have to get that multiplication on the right hand side. If you are going to multiply on one side, it is going to be equal, right? So on the left hand side also, on the right hand side, if you are going to get that multiplication, then only it is correct. But that first one without any multiplication in the first relation, yeah, we are obtaining for this one, the very first relation, it is correct. If you want to get this relation, you have to get multiplication on one side only. But according to the principle of homogeneity, you have to take that operation on both the sides, right? All right, just you will take this one very clear, very clearly we will take this one. This is the correct one, right? Okay, if you are going to look into that matter of these type of problems, you should get that relations. What are the relations? Energy and force. If you are going to take that, work done is nothing but energy. Work done is going to be in the form of potential energy. So work done is equal to force into displacement. You have to get that relation. That is work done. That is equal to force into displacement. Yeah, if you take that displacement by time, that is related to velocity. So these kind of problems are frequently asking in the entrance examinations. So you need to know about all the relations, which are very, very important. If you are going to take that pressure, so force by area, that gives the pressure. If you know that force and you know that area, you will calculate that, all these things. Right. Okay, all of you, if you are going to have that continuous monitoring and continuous observation of all these problems, we have explained very neatly, and we are here to work for the students, those who are going to be facing that entrance examinations, and those who are ready for that entrance examination to crack the IIT and NEET and other competitive examinations. So for all the students, we are providing that very good opportunity. Make it proper use and convey for others also. Thank you very much. Have a nice day.